All right, so here we're given a related rates problem. We're told that the man is 6 feet tall, so here is 6 feet. The light is 15 feet tall, so this is 15 feet. And the man is 10 feet away from the base of the light. So let's cut it here and call this value x equals 10 feet. And it asks at what rate is the length of the shadow moving and at what rate is the tip of the shadow moving. So what is the difference? Well, the tip of the shadow, let's say this is his shadow. The tip of the shadow encounters the speed at which he leaves the light in addition to which the shadow is growing. That's a tip. That's the tip of the shadow. The length of the shadow is only this length. All right, so the length of the shadow is how fast the shadow is growing. The tip of the shadow considers in the speed he's walking away from the lamp as well. So let's call this x. Let's call this s, and we don't know s yet. All right, and let's call this entire thing x plus s equals total length. All right, so first let's do big triangle, big length over big length, little length over little length. All right, this is two similar triangles. So 15 over x plus s is equal to 6 over s. All right, so if we cross multiply, 15s is equal to 6x plus s. So this will be 15s is equal to 6x plus 6s. So my bad. So this will be 9s is equal to 6x. Now if we derive this, we'll get 6 ds dt is equal to 9 ds dt is equal to 6 dx dt. All right, we are given dx dt because oh shoot, I forgot to write this. But in the problem, you're given that man is walking away at 5 feet per second. All right, so we're given that dx dt is equal to 5 feet. So with this information given to us, we now come back here and plug 5 in. So it's 9 ds dt is really 30. 5 times 6, 30. And 30 divided by 9, 5 times 6, 30, yeah. And then 30 divided by 9, ds dt is equal to 10 over 3. So that gives us ds dt. So ds over dt is equal to 10 over 3 feet per second. All right, that doesn't matter. So ds dt, this should be feet per second as well. So ds dt is 10 over 3 feet per second. This is the rate at which the length of his shadow is increasing. So that increases question A. Question A is 10 over 3 feet per second. That's the length, which is ds dt. Now we're finding the tip of the shadow. The tip of the shadow is both of these included because the man is walking away at the lamp as well. So now we need to consider L, which is the combination of dx and ds. X plus x equals L. So now let's come up with a new equation. 15 over L is equal to 6 over s. 15 over the long side, x plus s, which is L, over 6 over s. So big triangle over small triangle. Again, big triangle and small triangle again. Big triangle is 15 over L, small triangle is 6 over s. So now we have 15s is equal to 6L. Derive this, 15 ds dt is equal to 6 dl dt. We already figured out ds dt from here. So 15 times 10 over 3 equals 6 dl dt. Now if you do 150 divided by 9, no, divide by 18, right, equals dl dt. And if you do 150 divided by 3, it will be 50 over 6, which is equal to 25 over 3. And that is equal to dl dt. All right, so 150 over 18. So 15 times 10 is 150 over 3, and then divide this 150 over 3 by 6 will be 150 over 18, and then 150 over 18 equal dl, and divide both up and down, and if you simplify that, it will be 25 over 3. So this is feet per second, and this is dl dt. So that is dl dt, and dl dt is the speed at which this entire thing is moving, which is also the rate at which the tip of the shadow is moving. So which will be dl dt, and that is equal to 25 over 3 feet per second. All right, that's it, and that's how you solve this shadow problem. So the main thing is just to know you have to use a lot of relationships of the length of the height of the big triangle over the length of the big triangle and compare that to the height of the small triangle and the length of the small triangle, which you'll be using variables for. Thank you for watching. I hope this helped.